Hello dear students, now let us take the new topic measurement of very small distance size of the molecule. See, we are taking the size of the molecule which is range between 10 raised to minus 8 to 10 raised to minus 10 meter. So, to measure the size of the molecule, we can't use a screw gauge or similar instrument. Even an optical microscope uses visible light having the wavelength 4000 angstrom to 7000 angstrom. Here 1 angstrom is 10 raised to minus 10 meter. So this microscope can't resolve particles with size smaller than this. The resolution of the electron microscope is 0.6 angstrom is limited. It can almost resolve atoms and molecules in a material. There, electron behave as wave, not a particle. Even tunneling microscope has been developed, gives better result than electron microscope. So, we are taking the so many high technological device, but one simple method also we are using. A simple method for estimating the molecular size of the oleic acid is given here. This type of the method is known as the monomolecular layer method. So now let us understand what is the monomolecular layer method. We are taking this method right now. Now let us take this method. In this method, we are taking the oleic acid. The oleic acid is a soapy liquid with large molecule size of the order of 10 raised to minus 9 meter. So what is the method here? First, form layer of oleic acid on water surface. Dissolve 1 centimeter cube of oleic acid in alcohol to make a solution of 20 centimeter cube. Now take 1 centimeter cube of this solution and dilute it to 20 centimeter cube using alcohol. So the concentration of the solution is equal to 1 by 20 into 20 centimeter cube of oleic acid per centimeter cube of solution. Next, we lightly sprinkle some lycopodium powder on the surface of water in a large trough, and we put 1 drop of this solution in water. So the oleic acid drop spreads into a thin, large and roughly circular film of molecular thickness on water surface. Then we quickly measure the diameter of the film to get its area, capital A. So dear friends, in this method we are taking the oleic acid solution and it mixed with the water and it spread on this water and we get the solution, and this solution is mixed with the alcohol. Then we are taking the dilute solutions 1 part and we sprinkle the lycopodium powder and we get the thin circular film of the molecular thickness on the water surface. So then we quickly measure the diameter of the thin film to get the area. So here we get the area and the thickness, and how to calculate it. Now let us see the calculation. In this calculation, initially we determined the approximate volume of each drop, that is the V centimeter cube. Volume of small n drops of solution is small n into capital V centimeter cube. So amount of oleic acid in this solution is equal to small n into V into 1 upon 20 by 20 centimeter cube. This solution of oleic acid spreads very fast on the surface of water and forms a very thin layer of the thickness T. If this spread to form a film of the area, then the area is taken as the capital A centimeter cube. Then the thickness of the film is given by the small t. So this thickness of the film is given by the equation T is equal to NV upon 20 into 20 A centimeter. If we assume that the film has monomolecular thickness, then this become the size of diameter of a molecule of oleic acid. The value of this thickness comes out to be of the order of 10 raised to minus 9 meter. So in this way we can find out the diameter and thickness of the given oleic acid molecule. Now let us take the unit. The range of the length, small unit of the length taken as the 1 Fermi is equal to 10 raised to minus 15 meter. 1 astronomical unit, it is the bigger unit, and it is equal to 1.496 into 10 raised to 11 meter. So the 1 astronomical unit is known as the average distance of the sun from the earth. Same way we take the very large unit, that is the 1 light year. 1 light year is equal to 9.46 into 10 raised to 15 meter. What is the 1 light year? It is the distance of the light travel in 1 year, that is known as the 1 light year. Here velocity of light is taken as the 3 into 10 raised to 8 meter per second. Same way the bigger unit is 1 parsec. 1 parsec is equal to 3.08 into 10 raised to 16 meter. Parsec is the distance at which average radius of the Earth's orbit subtend an angle of 1 arc second. So these are the big and small unit of the length. Now we are taking the measurement of the mass. The amount of matter in the substance is called the mass. Since it is the internal property of the matter, it does not depend on external circumstance like the temperature, pressure. Mass can be generally measured with the help of simple balance. We can also known as physical balance. Nowadays we use the electronic weight machine also. Large mass can be measured using the gravitational method. We will study this gravitational method in the chapter 8. So also we use the mass spectrograph method too. Now let us take the another point here, the unit of the mass. So while dealing with atom and molecule, the kilogram is inconvenient unit. So their mass is measured in atomic mass unit called AMU. The 1/12th mass of the unexcited atom is of the carbon 12 is called the 1 AMU. So 1 AMU is equal to 1.66 into 10 raised to minus 27 kilogram. Now let us take the difference between mass and weight. Mass, it is the scalar quantity, means it has only value, not the direction. It is amount of the matter in the substance. The unit of the mass is kilogram or the gram. The object's mass can be measured with the help of simple balance, and its value can't change with respect to time or the place. At the other side we are taking the weight. It is a vector quantity. The gravitational force mg act on an object of the mass m is called the weight. So we can write the w barabar mg of the object. So the unit of the weight is Newton or the dyne. The weight of the body at any place depends on the value of gravitational acceleration of that place. So weight has direction as well as the value, and its value can be varies place to place, and it is depend on the gravitational acceleration on that place of the object. Now let us take the another measurement of the time. In the early days, time was measured from the length of the shadows of object cast by sunlight. After the invention of the pendulum, there is much development has taken place in the measurement of time. To measure any time interval, we need a simple clock. In order to meet the need for a better standard for time, atomic clock have been developed. For the measurement of small time interval, we are using the camera, multi-flash photography, etc. are being used. The unit of the time is given as second. Other units are minute, hour, and the small unit of the time is given by the millisecond, microsecond, etc. So, in the next session, we will study about the error, accuracy, and precision of the given quantity, the types of the error, and the correction. In the types of the error, we will take the average error, absolute error, and the percentage error and the fractional error, and we will discuss about its illustration. Okay, thank you.